This is lesson 59. We're talking about experimental probability. Okay, and our objective is right here. We need to get that written down. Now, before we can do this, we need to know the difference between theoretical probability and experimental probability. Okay, so theoretical probability is found by analyzing a situation. It is what should happen. Okay, so say I wanted to find out how many times a coin would land heads up. Okay, so I want to know how many times of, oh, let's do getting tails, okay? How many times I would get tails out of 8 flips. Okay? Well, theoretical probability is what should happen. So the theoretical probability is 4 out of 8 tails over the total flip. Okay, or 1/2. That would be the theoretical probability. That's what should happen. I should get tails 4 times out of the 8 flips, or half the times. Okay, experimental probability is found by actually performing the experiment. So what actually did happen? Okay, so let's say I got tails 6 out of 8 flips. Okay, then my experimental probability of tails over the total would be 6 out of 8, or 3/4 of the time. Okay, now that isn't what theoretically should happen. I shouldn't, if I flip a coin 8 times, I shouldn't necessarily get tails 6 times and heads twice. Okay, but it is possible. So again, theoretical is what should happen. Experimental is what actually happened. Okay, when we talk about theoretical probability, that's used a lot in like games and stuff like that, or flipping coins, rolling dice, stuff like that. Okay, games of chance. Okay, experimental probabilities are often used for like sports or weather forecasting. Okay, what actually happened, things like that. So let's look at some examples of when we would use experimental probability. Okay, example 1 says a softball player has 21 hits and 60 at-bats. Express the probability the softball player will get a hit in her next at-bat as a decimal number with 3 decimal places. Okay, so basically what we're going to do is we're going to say that they got some number of hits out of their at-bats. And we want to know the chance that they will succeed, get a hit in the next at-bat. So if they've gotten 21 hits out of 60 at-bats, that's the experimental probability. That's what actually has happened. Okay? So the chance of them getting hit on their next at-bat should be the same as what they've done in real life here. So to solve this, we're going to take 21 divided by 60. Okay, well, 60 does not go into 21, but does go into 210 3 times. And that multiplies to get 180. If we subtract 210 we get 30, and we have to bring down a 0. And 60 goes into 305 times. Okay, so we got 0.35. Now, we want to express that as a decimal number with 3 decimal places. Okay, and the reason for that is because when you do batting averages in baseball, they always express it as a number with 3 decimal places. Okay, so instead of 0.35, we need to have another decimal place on the end. So we're going to say it's 0.350. And this is what would be called her batting average. Okay? So her batting average is 350. Okay, that's a really good batting average for a baseball player or a softball player. Alright? So the reason why we want to write our probability like this is because that's how it's customary to write batting averages. Okay? Or the chance that she'll get a hit on her next at bat. Alright? Let's go on to another example. A salesperson distributed free samples at the mall. It says 50 shoppers accepted the samples and 30 did not. What is the probability that a shopper at the mall will accept the salesperson's samples? Okay, so we've got some shoppers that accepted the samples. Okay, some that did not. And of course, whenever we talk probability, we need the total number. Okay? Well, it says 50 shoppers accepted, 30 did not, so that means the total shoppers has to be 80. Okay, and now that's important because when we're talking about probability, it gets out of the total. So we want to know what's the probability that a shopper at the mall will accept the samples. So we don't care about the did not section anymore. So we want to know the probability that they will accept. So that is 50 over 80. Okay, that's accepted over the total. Okay, so 50 out of 80 shoppers. So the probability then is 5/8. Okay, so the probability the shopper at the mall will accept the samples is 5 out of every 8 shoppers. Okay, all right, let's go on to our last example. Okay, example 3 says the commuter plane flight arrives on schedule 2/3 of the time on any given weekday. Okay, so that means that on Monday it's going to arrive on time 2/3 of the time. On Tuesday it's going to arrive on time 2/3 of the time, and so on. Heather wonders what the probability that will arrive on schedule on Tuesday, Wednesday, and Thursday in the same week. Okay, it says how could the experimental probability be found, and why is this impractical? Okay, so let's think about experimental probability. She would have to look at 1 week, okay, and check the arrival times on Tuesday, Wednesday, and Thursday for that week. And then she'd have to do the next week and check the arrival time on Tuesday, Wednesday, and Thursday. And then she'd have to do another week, okay? So she'd have to do this over several weeks to get a probability, okay, a good experimental probability. Because the thing about the experimental probability is the more times you do something, okay, the more likely it is to be correct, okay? The more times that you flip a coin and tell how many times you get tails, okay, that experimental probability should be closer to what your theoretical probability is. So when you do an experiment or experimental probability, you want lots of samples. Okay, so she could find this. Okay, she could get the experimental probability by checking the plane's arrival time. On Tuesdays, Wednesdays, and Thursdays for several weeks. Okay, so she could, sorry, I should say check. She could check the plane's arrival time on Tuesday, Wednesdays, and Thursdays for several weeks. And again, the more weeks she does it, the better answer she's going to get. So why would this be impractical? Okay, impractical means why would it be not a good idea, or why would it not work very well? Well, the answer is that she's got to do this every Tuesday, Wednesday, and Thursday for a lot of weeks. That's just going to take a really long time, okay? So it's impractical because the experiment would take a long time. Okay, so in this case, she wouldn't want to necessarily go see if the plane's on time every Tuesday, Wednesday, and Thursday and do that over a certain number of weeks. Instead, on the example here, part B, it says, how could the spinner be used to simulate? Well, 2/3 of the time, it's going to be on schedule. So they took a spinner and divided it up into 3 sections. 2 of those are on schedule, and 1 of those is not on schedule. So we could test this theoretically instead by actually spinning the spinner and seeing about how many times it should work out for Tuesday, Wednesday, and Thursday. Okay, so how could the spinner be used? Well, each spin could represent 1 flight. Okay, so she spins it once. That's 1 flight, either on time or not on time. Well, she could spin it 3 times in a row to simulate Tuesday, Wednesday, Thursday. So she could spin it 3 times. And repeat. Okay? So she could spin it 3 times and count how many it was on time and how many was not on time. Then spin it another 3 times for Tuesday, Wednesday, Thursday. and then spend another 3 times for Tuesday, Wednesday, and Thursday, and so on. Okay? So that'd be a lot easier than actually going to the airport or looking online for the flight schedule, seeing if it arrived on time, and doing that over a course of weeks. Okay, instead of taking her weeks, it might take her a few minutes to conduct this experiment. All right, so that's your lesson on experimental probability. Okay, so good luck on the homework.